Do not forget, you can support the channel with a like, and you can also subscribe to be aware of the latest published videos. Thank you. We hope that here you can find the latest news, ideas, and discoveries from the scientific world.
Will time run out? It's a disturbing idea, scarier even than the end of the universe, because in most common scenarios about cosmic apocalypses, there is still the comforting possibility that a new universe will form from the remnants of the old one. But if time itself can end, then there is no escape. There will be no time for anything else to form. And that's it. Point. In recent years, cosmologists have tried to answer this question. Maybe it's not such a terrifying idea to them because they are already familiar with the many possible endings of time that emerge from Einstein's theory of general relativity. This theory of gravity holds that when a star contracts into a black hole, its matter gathers at a point of infinite density called the singularity point, where all quantities become infinite and time stops. You could see what this means by jumping into the nearest black hole, an experience we could all enjoy if the universe ends in a big crunch, collapsing into a cosmic singularity. However, the theory of relativity is probably not an exact theory, and physicists suspect that these singularities described by the theory as point-like will be slightly distorted by the effects of quantum mechanics. If so, when space-time passes through the mixer of a whole black holes or will go through a big crunch moment, there may be enough wiggle room for space-time to survive and emerge on the other side of the black hole. Thus, avoiding a violent end, time could simply stop. One of the unique characteristics of time is that it has only one direction, from the past to the future. This follows from the fact that we know that the universe was once super dense. When everything was well ordered at one point, it was in a state of order, but as space expanded, everything acquired the ability to become disordered. After countless trillions of years, when all the stars have gone out and even the black holes have evaporated, all the matter in our universe might be equally distributed. Everything will be as messy as possible. Then there will be no direction of time, and not much will happen. However, at the subatomic scale, particles will continue to collide with each other, and occasionally these random collisions will lead to something more interesting. Fortunately, statistically rare occurrences could result in the formation of an orderly object, a glass of beer, say, or a confused Lemurian, that will be briefly affected by time. So, in this image, time is bad, but it has not yet come to an end. The true end of time could be dictated by the multiverse. Many models of the cosmos involve a form of expansion called eternal inflation, in which new universes are constantly being created, each with different properties. Cosmologists want to understand the range of possibilities, how many of these universes have stars, how many have matter, what proportion is hospitable to life, but they've run into a problem. In an infinitely multiplying universe, there are an infinite number of versions of anything, making the calculation of probabilities impossible. To overcome this difficulty, some cosmologists claim that much of the multiverse does not exist. By imposing an arbitrary fixed boundary in spacetime, they can calculate probabilities for our slice of the multiverse. For example, they use it to predict a value for the cosmological constant, the repulsive force that causes the expansion of the universe, which is close to the one measured by astronomers. While that's good news for cosmologists and their calculations, it's less good news for time. Rafael Bauso, a theorist at the University of California, Berkeley, pointed out that these probabilities are only plausible if the real multiverse is characterized by a finite time. If the boundary of the multiverse reflects reality, Bauso calculated that time probably only has a few billion years left. It sounds crazy, but in physics you have to be careful when it comes to discarding theories just because they seem crazy. Time has the right to ask for a second opinion in the hope of a better prognosis. Alan Guth of MIT and Vitaly Vanchurin of Stanford University in California claim that they can calculate the probabilities within the multiverse without decapitating time. But they don't rule out the possibility that it could be finite. If such an end is possible, what will it look like? Igor Smolyanov of the University of Maryland in College Park conducted an experiment to find out. As a substitute for the universe, he used a material made of plastic strips placed on a gold film, which bends the light in a specific way. In this metamaterial, an axis behaves like time, pulling light rays forward, a motion mathematically identical to the motion of light in spacetime. Smolyanov attached part of this metamaterial to a material through which light can move freely in any direction, meaning that there is no time axis. He discovered that at the border between the two environments, where time ends, light gathers, forming a strong electric field. The theory predicts that without energy loss, the electric field would increase to infinity. Our physical vacuum probably behaves like a metamaterial, so our experiments probably make sense, says Smolyanov. If the analogy is correct, then in real space all energy fields would be magnified to huge values, increasing the temperature and turning the last millisecond of existence into an inferno of particle creation. If you think everything is doomed to hell, you might be right. A more serene vision of the end is suggested by Julian Barber, a philosopher who collaborated with cosmologists in constructing a strange picture of reality that he calls Platonic. In Platonia, there are all possible configurations of matter. There is no phenomenon of the passage of time, only a multitude of unrelated moments, instances of the eternal present. We experience the illusion of time because many of these moments are arranged as if they evolved over time. Barber believes that the possibilities in Platonia should be infinite, and thus the comforting illusion of the existence of time should also be infinite. If time does not exist, it will not end. Predictions are difficult to make, said physicist Niels Bohr, especially about the future. So perhaps it is not so surprising that there is no definitive theory about the end of time.